Please. I'm gonna tell you to go downstairs. You don't want to go downstairs.
Please, chill.
Ish.
Yeah, I'm glad I didn't want to do that. The amount of money I'm not from this one, and it's left.
Me.
But it said 9 minutes.
It's probably not that one anyway. It's probably one before.
The other one is still saying, okay, 7 minutes. Okay.
Are you even at Manadine? Where are you?
Um, Stay alert.
Okay, can you see my screen, Mason?
Yeah,
Okay. So is this the kind of thing you guys did in class?
kind of. But like today we were like, yeah, I guess. You know,
Okay, so if you were to multiply this, how would you go about it?
so I'll get rid of the decimals, and then
Okay,
I'll do 5 times 12,
okay,
which uh, 5 times 12, which is 60.
yes.
And then I'll count how many decimal places there is. So in 0.05, there's one, two. So there's two decimal places.
Mm-hmm.
So that already. Wait, could you? So that already would make it 0. Wait, that already would make it. Hold on, that would make it 0.06, I think.
You're not sure?
That would make it. Wait, that would make it 0.6, I think.
Better. All right. So what next?
And then you count how many decimal place jumps there is on the 0.12, which is 1, and that will make your answer 0.06.
Now, if you look at the 0 point, what you call 0.12, it's actually 0.12. So if you
Mm,
are counting how many decimal places, there are actually two, not one. Okay.
mm,
So that means it's two decimal places. So in other words, you've already counted 6 and 0 as 2 for the 0.05. So if you count another 2, it's going to be 0.06. Okay, did you get that?
okay, yeah.
So your final answer would be 0.06. Okay. So um yes, this is okay for practice. Okay. All right. So all right, this is good. All right, so let's just look at um some other ones. Okay. So let's take a look at this one. Um 3 3.5 okay times 0.15. Okay, so what would you do in this case?
So like, then I'll see both of them as normal numbers. And then
Okay.
I'll do 5 times 15.
Mm-hmm.
What's 5 times 15?
Mm-hmm. What would that be?
525. And then in 0.15, I can see there's one, two. Actually, no, I can see there's. Is it? Is it one or two? I think it's.
Yes. How many decimal places are there in 0.15? Now, please take note.
There's
What?
two. There's two.
There's two. Good. So take
And then
notes. Yeah.
on
Go ahead.
3.5.
Mm-hmm.
So that would make the current answer 5.25. And then on
Mm-hmm.
3.5, there's one decimal jump,
Mm-hmm.
which would make it
Mm-hmm.
0.525.
Okay. All right. So technically, yes, that's three decimal places. So it's going to take us 0.525, correct? All right. So please remember again, once you have a decimal point, um, the number that comes after the decimal point is called by its digits. Okay, so 0.15 is actually the correct way to call the number. Okay, just like you called the other one 3.5, 0.15. Okay, okay, this is good. All right. Okay, so let's do one more to establish our practice. Then I'll maybe just show you how it is done um
What's the one?
for what do you call it? For division. Okay. So 0.11 times 0.19. Okay, so let me ask you, do you know okay, but okay, no, maybe let's just take on it. Anyway, so how would you go about this?
So again, I'd see both of the numbers as integers.
Mm-hmm.
And then I'll do 11 times 19, which
Yes.
is 209. Yeah,
Okay.
209. And
Okay.
then I can see in 19, there's 1, 2 decimal jumps. So that would make the
Mm.
current answer 2.09. And then in 0.11, there's 1, 1, 2 decimal jumps. So that would make the final answer 0.0209.
0.0209. Excellent. Okay. That's good. That's good. Okay. 0.0209. Okay. That's making a total of four decimal jumps, right?
Mm-hmm.
Okay. All right. That's good. Okay. So, what we're about to do now, right, is just a kind of uh, sneak or a peek into how it's done for division. Okay, so I want to believe since your teacher taught you this method for multiplication, which is
Mm-hmm.
the same method. If I were to teach you, this was the same method I would have taught you. I want to believe that your teacher would be teaching you exactly the same thing for um, the one I want to teach you for division. Okay, so let's take a look at an example for division. Then I'll do a couple of them and then see if you understood the concept. Okay, so for division, let's say we had six
I got this in me primary school.
points 6.25.
Mm-hmm.
Okay, divided by uh,
The opposite of me, actually.
0 point.
Yeah, I
Okay,
had.
so let's just make it 0.5. Okay, so I just want to start with this one that looks pretty straightforward. So 6.25 divided by 0.5. Now, for division, right, something that we need to do is this. We need to establish what number. Of course, we know the number on the left is the numerator, right?
Mm-hmm.
Okay. And the one on the right-hand side is the denominator.
Mm-hmm.
So do that, then that means this question would look something like this. 6.25 over or divided by 0.5. Okay. All right. Now, the next thing we're going to do is we're going to look at the number that has more, like you said, more decimal jumps. Okay. So if you look at 6.25 and 0.5, which one would you say has more decimal places or more decimal jumps?
6.25.
Exactly, correct. 6.25. So what we're going to do is we're going to like make it, look for how to make it a whole number by making the decimal jumps go toward the right-hand side. Okay. Now, take note of the number of decimal jumps. There were how many decimal jumps to make it a whole number? 2, right?
Mm-hmm.
So we're going to do the same thing to the guy underneath. That's the 0.5. Now, we know that the 0.5 has only 1, but because there's this law that says whatever it is that you do to the numerator, you must do the same thing to the denominator. Then you would have to do the same thing for the guy underneath. That means we're going to do 2 decimal jumps, 1 and 2.
Mm-hmm.
And anytime there's no other number behind the number that you are doing a decimal jump for, just put a 0 there. Okay. So in other words, our question now looks like this: 625 divided by 50. Can you see that?
Yeah.
Okay. So of course, you know what's going to happen, right? 5 in 50 is 10. 5 in 625 will give us 5 in 6 is 1. Remainder 1. In 12, that's 2. Remainder 2. And then in 25, that's what? 5. So that's 125, right?
Mm.
Now, if we remember that anytime you divide a number by 10 or a power of 10, then there's a decimal jump towards the left-hand side once. Okay? There's a decimal jump towards the left-hand side once. Why? Because there's only 1 0 in 10. Did you get that?
Mm-hmm.
Okay. So once you remember that fact, then we have it that 125 will become 112.5 because you were dividing it by 10. Now, based on what I just explained, let's pretend, now this is not what happened here, but let's pretend we had 100 in the denominator. Then that means that we would have had 2 decimal jumps. That means it would have been 1.25. Did you get that?
Yeah.
Okay. All right. So let's do one more example for division. Now, so you can see division's rules are quite different from multiplication, right?
Yeah.
Okay. So let's do one more example for division so that we will establish the principle for division. Okay. So I'm just coming up with these numbers. 72.9. Okay. Divided by 0.09. Okay. So if we are to apply the rule, the first thing we'll do is to interpret it the way we usually interpret it. The one on the left-hand side is the numerator, while the one on the right-hand side is the denominator.
Yeah.
Okay, so this is how it's going to look. 72.9 divided by 0.09. Okay, so again, I want you to take a look at these two numbers. Which one has more decimal jumps or decimal places?
0.09.
Correct. So we're going to work on 0.09, moving the decimal jumps towards the right-hand side to make it a whole number. Okay, so we notice that we need two decimal jumps to make it a whole number. And whatever we do to that denominator, we're going to do it to the numerator. So in this case, we're going to also make two decimal jumps for 72.9. Now, because there's no number after 9, we're going to put our trusty old 0 there, and we're going to have 7,290 in our numerator. Okay, so let's see how that plays out. 7,290 divided by 9. Okay, can you see how it looks now?
Yes.
Okay, all right, so we're going to go like this. 9 in itself goes in there one time. 9 in 72 goes in 8 times. Okay, 9 in 9 is one time, and of course 9 in 0, we'll just put 0 there. Okay,
Yeah.
so now in this answer, take a look at this. It's a whole number. Okay, 810. All right, now you would find that this is a very possible scenario. Yes, two decimal numbers dividing by themselves, and the answer is a whole number that doesn't seem to have a decimal point in it. But we all know that all whole numbers actually have their decimal points behind the last digit. So 810 is actually 810.0 if you really wish to represent the decimal point. Otherwise, you can just leave it as 810. Okay, you got that?
Mm-hmm. Yeah.
Okay, all right, that's good. All right, so I'm going to show you one more scenario. Of course, I'm sure you've gotten the drift by now, what you should do for division. But let's pretend that both of them have the same number of decimal jumps or decimal places. What's going to happen? Okay, so let's look at this setup. 0.039, yeah,
Yeah.
0.039 divided by 0.013. Okay, so what did you notice in this instance?
They both have the same amount of decimal places.
Exactly. Okay, so in this case, I guess it's easier, right? You can tell how many decimal places, how many jumps we would need to make both of them whole numbers, right?
Yeah.
So it's just going to play out like that. 1, 2, and 3. Okay, and the same thing is gonna go for this guy. The one in the denominator, 1, 2, and 3. Okay, so at the end of the day, what you actually have is 39 divided by 13, okay, which is simply 13 goes in itself one time, 13 goes in 39 3 times. So our final answer is 3. Okay,
Yeah.
all right, you got that?
Mm-hmm.
Okay, good. All right. So I just thought it would be nice if you had this information before you went for your next class. Okay, but I want to believe that seeing it again in class would be a means of helping you to remember it for good. Okay, but I like the fact that you quickly learned the method for multiplication, and you remembered it. Okay, all right. So, do you have any questions?
Uh,
Do you have any questions?
wait, mm, can I please see like another example of question 6?
Okay, okay, okay. For multiplication or for division?
Division, the same as number 6, like when it's the same
Okay.
when it's the same amount of decimal jumps.
Oh, okay. All right. Okay. All right. So let's do one more example. All right. Okay. So let's say we have this arrangement 0.027. Okay. Divided by 0.003. Okay.
Okay.
Yes. So the same thing is gonna happen here. Both of them have 3 decimal places. So if we want to make them whole numbers, we'll have to do 3 decimal jumps to the right hand side, and that will leave us with 27 at the top. And then in our numerator, if you do the same thing, it's gonna be 1, 2, and 3. Okay, so that's going to leave us with just 3. Okay, and then when
Okay.
we now go ahead and say 3 in itself is 1 time, 3 in 27 goes in 9 times, and so our final answer would be 9.
9. Oh,
Yes,
okay.
yes,
Thank you.
yes. All right. So I know that for decimal numbers, right? They usually teach you guys addition and subtraction probably earlier than multiplication and division. So do you still, let me just be sure, do you still remember how to carry out your addition and subtraction for decimals?
How to add and subtract decimals.
Yes,
Yeah.
you still remember, right?
Mm-hmm.
Okay. All right. So this is just me checking out your skills if you still, if you aren't rusty with it. So let me ask, if you wanted to do something like this, 1.384, okay, plus 2.5. How would you go about it? What's the first thing you're gonna do?
So the first thing I would do is,
Yes,
so since 2.5 is bigger, I'll put it at the top. So I'll put 2.500.
2.5. Are you sure you want 2.5 to be at the top?
Okay, I don't just put does it just put 1.384 at the
So
top then.
let me show you why I would advise you still leave it as 1.384 plus 2.5. Now, you know it's addition, right? So I mean, whatever is at the top really doesn't matter. But let me show you why it would be a good idea to leave 1.384 at the top. So I guess if you have 1.384 at the top, right, what you essentially want to do is to make the decimal points line up, right?
Mm-hmm.
Okay. So underneath, you're going to bring your 2 to line up right under 1 because that's the only time that the decimal point after the 2 would line up with the decimal point after the 1. And then you have 2.5. Now, the good thing about it is you would know how many zeros you would have to write after the 5 so that it's kind of balanced. You understand what I mean, right?
Yeah.
Okay, so this is why I thought it would be a nice idea to just leave it the way it is. You know, 3 plus 5 is 8, and 1 plus
Is the
2 is 3. Okay, all right. So we're good with this, right?
yeah.
Okay, so um, I'm not going to bother with subtraction because I want to believe that you know it's the same principle. We're just simply lining up the decimal points and uh, going ahead with our subtraction in that light. Okay, so let me just check in with you as per multiplication and division of decimals. You're good with what's the skills for both of them?
I think maybe only division. I
Okay,
think
only
maybe
division, right?
yeah.
Okay. So you feel you're good with multiplication.
Yeah.
Okay, that's good. All right, so let me just check in one more time. Now you remember when I told you that when you are dividing by 10, numbers like 10, 100, 1,000, 10,000, whenever you're dividing by numbers like that, you would find yourself doing decimal jumps to the left-hand side.
Mm-hmm, yeah.
Okay. Now, of course, the opposite is the case. If you find yourself multiplying by 10, 100, 1,000, 10,000, etc., you would have to do decimal jumps towards the right-hand side. Okay.
Yeah.
So what I want you to factor in your mind is this. Whenever you're multiplying by powers of 10, your decimal jumps are going to the right-hand side. Whenever you're dividing by powers of 10, your decimal jumps are towards the left. Is that something you would remember?
Wait, can you please say that
Okay, you
again?
want me to take it again?
Yeah.
Okay, don't worry. I'm just going to do a few examples, right? I said anytime you're dividing by a power of 10,
Mm-hmm.
like 10 itself, 10 is a power of 10 because that's 10 raised to power 1. 10, 100, 1,000, 10,000, etc. Anytime you are dividing, the decimal jumps would be towards the left. Okay,
Okay, yeah.
towards, yes. And then anytime you're multiplying by powers of 10, your decimal jumps will be toward the right. Okay.
Mm-hmm.
Now, in case you're wondering how many times you're going to do the decimal jump in each case, simply count how many zeros are in the power of 10. Okay. So, for instance, let's say you had this scenario. Let me just come up with one scenario here that's quite straightforward. So, let's say we had uh, 1 point. Okay, so let me just come up with this. One okay, so let's say 18 0.13, okay, times, let's say 1,000, okay? So how many zeros do we have in this case? In the power of 10, we have 1,000, right?
Yeah.
So the decimal jumps would be number one, 3 times, and they would be in the right hand side, okay?
Mm-hmm.
So always remember, whenever the number of jumps exceeds the number of decimal places, then you have to put a 0 behind it. So for instance, 18.13 is going to become this after the multiplication. Okay, so don't forget, you have to do one more decimal jump for this scenario. So it's going to become 18130. Okay, so that's 18,130. Okay, did you get that?
Yeah.
Okay, and of course, on the flip side, if you were doing a division, let me just give an example. If you are doing a division and you had something like this, 6.35 divided by okay, so let's say divided by 100. Okay,
Mm-hmm.
so in this case, I have two zeros, and my zeros will tell me how many times I'm going to do the decimal jumps. But because it is division, decimal jumps are going to be going to the left. So this is where my decimal point is, and it's going to go over 6 one time. And then since there's no number after 6, we're simply going to put a 0 there. Okay, so that's going to leave me with 0 0.0635. Okay,
Mm.
all right. So did you get that?
Yeah.
Okay, that's good. Okay, so I'm pretty sure that we would have more opportunities to do some exercises on this. So maybe after our Friday class, maybe I'll look for some questions you could work on over the weekend, or probably there in class, and then we'll be able to get more practice opportunities for practice in our class. Okay,
Okay.
so you're good with this?
Yeah.
Okay, that's fine. All right. So your next math class in school is when? Wednesday or Thursday?
Tomorrow.
Tomorrow. Excellent. Is that the last one for the week?
No, no, no.
Okay,
I
you still
think
have another
t
one.
tomorrow I'll get my score because
Oh,
my teacher said tomorrow. I'll send
oh,
it to the group chat.
oh, okay, perfect, perfect. That's good. That's good. All right. Okay, so I'll be looking forward to it. I think you're pretty good for this. So I'll send you this file on WhatsApp so you can take a look at what we did today if you need to make references to it.
Okay.
All right. Okay, so I think it's fine if we call it a day here, and uh, yeah, we could end it here.
Okay.
All right. So do have a good rest of your evening.
All right. Thank you.
Okay. You're welcome.
Okay, bye.
All right. Bye.